Hey everybody, fun science video for you. Today, we're going to talk about the law of conservation of mass. So let's get started. First thing I want you to do is I want you to go to your book on page 446. And I want you to make sure you have an answer written down for number 13. Pause the video right now and actually write an answer to 13 to see if you're right. Today during the video, there's going to be 6 points that we're going to discuss. All right. And when we discuss these things, you need to make sure that you have the answers down in your book or in your notes in some way. So point 1 was, what does the law of conservation of mass state? In other words, what did you just write? You should have wrote on that the law of conservation of mass states that mass is not created or destroyed, but it's only transformed into different substances or forms. And so that's the first thing that you should have written down. So this is really easy to see with things that are physical changes. Let me show you what we're talking about. So when you look at these Lego men figures in your book, all right, the Lego man has transformed in the before and the after. But it's really easy to see that mass was not created or destroyed. What did you write for your answer down about how is the physical change in this robot reversible? And how can you tell that the change follows the law of conservation of mass? Well, the part I want you to focus on is how can you tell that this change follows the law of conservation of mass? Go ahead and pause the video. What did you write for that one? Okay. Well, hopefully you wrote an answer on that the Lego man, even though it changed in appearance, all right, it still has the same number of pieces. If you count this piece right here as a piece, then there's 11 pieces. If you don't count that piece, there's 10 pieces. So, but the same number of pieces are there for each one. See, this is really easy with physical changes to see the law of conservation of mass. But sometimes students say, you know what? I've seen examples in my life where the law of conservation of mass just isn't true. And sometimes people say things like, to me, they'll say things like, hey, Mr. Callahan, I've seen a piece of wood, and when I burn the piece of wood, it turns into ashes. And the ashes are nowhere near the same mass as the piece of wood that I started with. So you're wrong, Mr. Callahan. The law of conservation of mass doesn't work. So let's talk about that a little bit, and let's start to do an experiment to see what people are talking about. So what we're going to do is we're going to do an experiment. We're going to do the experiment that's in the book right here, except we're going to actually run it like a real experiment. Remember, in science experiments, you need to make sure that you do some things and you keep some things the same. What are the things that we keep the same in a science experiment called? All right, go ahead and pause the video and answer that question. Okay, so again, this is point number 3, by the way, of the third thing you should have written down in your notes. The second thing was you should have a good answer to number 14. The third thing is hopefully you came up with the things that we keep the same are called constants. All right, so in this little experiment, we have to make sure that we actually keep some things the same. So here's some things that we're going to do in this experiment. First of all, we're going to use 50 milliliters of vinegar. All right. You might want to write a materials list down of what we're doing. We're using 50 milliliters of vinegar. Second, we're going to go ahead and use 1 teaspoon, all right? And since this is science class, I went ahead and weighed a teaspoon of baking soda. And a teaspoon of baking soda weighs 5 grams. So we're going to use 5 grams of baking soda. And what we did was I took a flat teaspoon, kind of used a knife and scraped it off the top, and I measured that out, and again, that's 5 grams of baking soda. I'm gonna make sure that I use the exact same amount of baking soda and the exact same amount of vinegar in each experiment. One thing I am changing, though, by the way, in this experiment, that is not a big deal because it's still a flask, but I'm gonna have one flask that's a little bit smaller than another flask. And that's just because I set up the experiment ahead of time. And I wanted to make sure that I could do the video kind of quickly. All right, so what we're gonna do is we also need, as you look in the book, we need a balloon, okay? So I have, as you can see right here, I have a green balloon, and these two balloons are the same. So I have two green balloons. They're both the same. They're identical in color. They're also identical in size. And I also massed them out. They were identical in mass. So everything about them was, in fact, the same. So what we're going to do right now is I took, first of all, for the first test, we're going to actually use the balloon kind of like a spoon. And what we're gonna do is we're gonna take the baking soda, we're gonna put it into this flask, but we have to get a starting mass. So here we go. I'm gonna just show you right now that the balance reads, we'll go ahead and look at it. We've got 100 there, plus 60, we've got 169.5 grams. So what we're gonna do right now is we're gonna go ahead and carefully put this baking soda into this funnel. And we're gonna kind of shake it down in there, and we're gonna shake it in there, and we're gonna watch what's going on, all right? So I'm gonna go ahead, since I used it as a spoon, I'm gonna go ahead and put this back in here. And what you wanna do right now is you wanna make a prediction. What happened to the mass, all right, of this? What do you think just happened to the mass? So I still have the flask. I still have where I put the baking soda in. You saw this big reaction of bubbles, and I still have the balloon sitting on there. So what happened to the mass? Pause the video and make a prediction. Okay, hopefully you're back. Hopefully you wrote a prediction down. Let's see. Now you notice that the balance is reading with it down, which just appears like the law of conservation of mass isn't true, because the mass, where did it go? Where did the mass go? All right, this was a chemical reaction, and see, Mr. Callahan, the mass is less. So what happened to the mass? Well, what we're gonna do is, first of all, we're gonna go ahead and record. Remember, we started with a mass of 169.5. Hopefully you have that recorded. And what we're gonna do is we're gonna see what it went down to. All right, and we could see that it actually went down to 168. All right, so it lost 1.5 grams. And it's like, okay, Mr. Callahan, the law of conservation of mass says that the mass should not go down. All right, the mass should not go down, okay? So what we're gonna do, all right, is try to prove that the law of conservation of mass is actually true. So some of you hopefully can figure out what happened to the mass. So pause the video, but write down what you think happened to the mass. All right, well, hopefully some of you said, well, some of those gas bubbles that were produced left the flask, and when they left the flask, they caused the mass to decrease. All right, and so the mass is still there, it's just out in the air. Well, if that's true, we should be able to prove it. So the next thing I want you to do is we're going to manipulate just one thing. All right. In science, what is the thing you manipulate or test called? Go ahead and pause the video. This, by the way, is the next point you should be writing down. So that is now the fourth point of something that you're supposed to be marking down, all right? Remember, we stated the law of conservation of mass. We also figured out how the Lego man and the physical change. It still had the same number of something. Hopefully you got that down. The third thing that you were supposed to write down was what happened to the mass when we didn't have, when we just poured the baking soda in, and we saw that the mass went down. The fourth thing that you should have written down, sorry, this is going to be the fifth point we're working on. The fourth thing that you should have written down is what are the things we keep the same called? And now the fifth thing you want to do is what are the things we manipulate called? Please write that down and pause the video. Hopefully you realized that it was called a variable of some kind. It's actually known as the independent variable. And hopefully you wrote down that the thing you manipulate or change is the independent variable. So what would be an idea of a way we could change just one thing, but we could keep the mass that you guys think is going out the top from escaping? So what could we do? What's one thing we could change in our test? So go ahead and pause the video and tell me what you think we could change. Okay, you're back, hopefully. So here's one thing you could change, all right? What we could change is we could change the way we started, all right? So what we've done here instead is now we've taken the balloon and we've attached the balloon to the flask. And I went ahead of time and put the 5 grams of baking soda in. And I also went ahead of time and I also ahead of time put this onto the flask. Now, one other thing I did ahead of time was, since this is a little smaller flask, I went ahead and I got the mass of this one because this flask is a little smaller. It does still have 50 milliliters in it. And by the way, I measured out the 50 milliliters for both of them in a beaker. And that's another material you should probably have in your materials list. And I measured it out in a 50 milliliters of vinegar in a beaker, and I had put the 50 milliliters into both flasks. And so you can see right there that has, in fact, 50 milliliters of, it says 50 right there, and it's right on the line of 50. So we have 50 milliliters of baking soda in there. The other thing I want to show you is that right now I have got the mass set, all right, for this second trial. Now, the only thing that's different is the mass is a little less, like I said, because it's a smaller flask. But everything is the same quantities. Everything's the same, except we've changed this one thing. We've attached the balloon to the funnel. And so the baking soda is already in here. And what I'm going to do is I'm going to lift this up and I'm going to kind of shake it into there and we'll let it do. So this mass of the smaller one with all the stuff on it is 141.5 grams, all right? So what we're gonna do is we're gonna go ahead and start this one's reaction. We'll let that shake down into there, and check it out. We're noticing that the balloon this time is filling up. It's filling up, but notice the mass isn't changing. The mass is staying the same. So the mass is filling up the balloon, but the mass is staying the same, okay? Now, this is pretty darn cool, all right? The mass this time stayed the same. We're still at 141.5 grams, which is pretty darn sweet, all right? And one of the things that's really, really cool about this is that as it is doing that, okay, as it is doing that, again, what's really, really, really neat, okay, is that it's kind of like making the reaction. And so it's filling up the balloon, as we can see. But again, if we look over here, the mass has stayed exactly the same. And so we see this, here it is. And now we've proved that before that mass truly did go up in the air and that mass is conserved. Now, we do have different things. We have this gas that wasn't there before. It was produced, but it's now, so the substance is changed. There's a different substance, but the mass is in fact conserved. So we have actually 0.6 you want to write down here. If the mass stays the same, we have in fact proved the law of conservation of mass. So, hopefully, you learned something today about the law of conservation of mass. Everybody, you need to make sure you have those 6 points we talked about in the video. Make sure you're taking notes on those things, because I'm going to ask those exact same questions in class, and you're going to be tested on them as a class. So I sure hope a bunch of your classmates actually watched the video. Have a great day. We proved the law of conservation of mass. Have a great one. Bye.